Questions on, let's go 1 through 10. Okay, on 11 through 14, when they give you the interior angle measure, it's a lot easier to use that to find the exterior angle. So if the interior, again, it's irregular, so all of the interior angles will be 108, all of the exteriors will be 72. And then you can just do, since they all have to 360, you can just do 360 divided by 72 to figure out how many 72-degree angles there are to add up to 360. So that's what you're going to see me do on all of those. I mean, the exterior angle and then just dividing by the exterior angle measure. Okay. For the sum of the exterior angles, it's always 360. The sum of exterior is always 360. And then again, for finding the number of sides, if they give you the exterior angle, it's the same thing we're doing up here, except that they've already given you the exterior angle. You can just divide 360 by that to figure out how many there are. The number of sides is the same as the number of interior angles, the same as the number of exterior angles, the same as the number of vertices. Okay. And then 23 and 24, the quad will add up to 360. The pentagon adds up to 540. So make sure that you're using the correct sum for that. Okay, anything through number 24? No questions. Okay, let's skip 25 and 26 for a minute. Why is this one no? Paul. Right. Yeah, so if it does not divide evenly, then it's not possible to have a regular polygon with those interior angle measures. Okay, and then here's the true false. So that R was weird. All right, how about questions on 29 or 30? No questions on 29 or 30? All right, guys. Okay. Did everybody figure out how to do 25 or 26 other than just kind of guessing and checking and kind of figuring out how to finish off the shape? You're able to do calculations and tell me what to do. So
for 25, I did the same thing. I just did the exterior angles
Mhm.
and then found the mean, and then divided 360 by that.
Okay, tell me why that makes sense.
Because they're alternating. So if you the mean, then that's just the average. Then you just find the number of the exterior.
Okay, so you did 360 divided by 45 is 8. Paul, what did you do? Okay, tell me why you doubled. Okay, you combine them into one, meaning that Paul was using, if you add 30 and 60 to get 90, he's kind of pairing those up, right? So he's saying there are 4, if you paired up a 30 and a 60, there's 4 30-60 pairs, which means you have to double in the end. So this means there's 4 pairs of 30-60s, and then you have to double because you're kind of like taking those pairs and pulling them back apart. The way that Seth did it, he's kind of like saying when you average the 30 and the 60, it's sort of like you're pretending it's regular, right? It's going to work out the same if you alternate between 30s and 60s, or if you just made it regular where they're all 45s. So when he did the average, he doesn't need to change his answer because that's the same thing as saying there would be 8 45-degree angles. It's the same as saying there's 4 30s and there's 4 60s. Okay. Neely, do you have a question or a comment? Nothing, you're good. Anybody do it a different way? Show me calculations. Okay, that's good. So let's kind of talk through somebody else then tell me how to use one of their methods to do number 26. Let's talk through a different one here. Oh, go ahead.
I added up all the interior angles
Okay.
and multiplied the sum of them.
Okay. You're kind of looking at this and thinking, you were kind of visualizing that as equaling half of the polygon, right? Okay, so that's kind of looking at it and sort of guessing that that's half of it. So I really want a way that will use calculations that doesn't require like guessing and checking basically. Did anybody do it with an equation with the interior angles? I wouldn't recommend that, but you could. Okay, let's use exterior angles here. So Jake, what's that exterior angle going to be? Okay. Okay. Julia, what's this exterior angle? $30. Not 8, 30 what? Okay, so someone who is not Paul or Seth, tell me what to do with those numbers. Lucy? Okay, that's 72 divided by 2 is 36. Then what? Okay, so again, what you're doing, if you do it that way, is you're saying having angles, exterior angles alternating between 40 and 32 is the same as saying that all of them are 72 degrees. So again, on that one, you don't have to double. If you do 360 divided by 72, you're going to have to multiply by 2 in the end. Now, I'm going to show you a bunch of different ways that you could do. So here's number 25. Okay, this is, that's what Seth said. This is what Paul said. Okay, that's what I would recommend, is using the exterior angles. You can use the interior angles, but look at this. If you use interior angles, you're going to end up with these equations that you have to solve, which not like it's impossible to do that, but it's just irritating, right? So one option is you can average the interior angles instead, and it takes n 135 degree angles to add up to n minus 2 times 180. Like if you use the interior angles, you can't just put a 360 there. You got to use the n minus 2 times 180. Okay, so these will work. This is kind of the same thing as what Seth said, except using interiors. And this is the same thing as what, I think, yeah, as what, or no, backwards, I don't know. One of them said that, and one of them said that, except that instead of using interior angles, but exterior angles, it's using interior angles here. Okay, if you want to take screenshots of anything, feel free. So that's at least 5 different ways of doing number 25. I would recommend sticking with the exterior angles. Okay, and then 26. I'll move that over so far. Okay. Those are just using the exteriors, because again, you could make equations with interior angles. It's just a lot easier to use the exteriors. Now, you could do these by guess and check, but I really don't want you doing guess and check. I want you to be able to do a calculation and come up with the answer. Josh. 27. This one? Any other problems on homework that you'd like me to go over? Okay, we're going to be doing lesson, your homework will have some more review of lesson 6.1. We're going to be doing lesson 6.4 on special parallelograms. Okay. So today's photo, you should see lesson 6.4. Please get in the habit of renaming when you import, you know how it gives you that stupid name. Some of you, when you're doing your submissions, I can tell you're not renaming your documents. You're going to have a huge mess if you just keep importing things that look like that. Please take the time to rename your. This is lesson 6.4, and it will be on rectangles, rhombuses, and squares if you want to name it that. Okay, it's on rectangles, rhombuses, and squares, lesson 6.4. Okay, here are definitions. Okay, a rhombus. A rhombus is a parallelogram with 4 congruent sides. Okay, a rhombus looks like this. Yeah, all 4 sides are congruent. Okay, it's kind of redundant to say parallelogram here. Why would it be enough to say a quadrilateral with 4 congruent sides? Why is that sufficient? If all you knew is it's a quadrilateral with 4 congruent sides, why would that make it a parallelogram?
Because if it's a parallel, if it has two pairs of opposite sides, it's already a parallel.
Okay, it's a quad with 2 pairs of opposite sides congruent, so it would make it a parallelogram. In the definition of your book, they'll say parallelogram because they're just trying to emphasize, what that looks like. But a rhombus will have 4 congruent sides. Okay, a rectangle, a parallelogram with 4 congruent angles. And since they're congruent, they're also what? What kind of angles will those be? Right angles. I actually don't remember which way they said it in your book, but okay, a rectangle, if I just did that, why would I not have to tell you it's a parallelogram? Why would I be allowed to just say quad and it would be sufficient? How would you know that that's a parallelogram? Julia? Yep, you could use that it's a quad with 2 pairs of opposite congruent angles. You can also use, when you go all the way around, these two are what? Supplementary, and so are these two. Therefore, it satisfies the 1 angle supplementary to both consecutive angles requirement. Okay, so again, it would be sufficient just to say quadrilateral. And then a square is a parallelogram with 4 congruent sides and 4 congruent angles. Can you give me a special name for a square? A square is the only quadrilateral that is what? 4 congruent sides and 4 congruent angles. Well, okay, so it has 4 congruent sides, so it's equilateral, but so is a rhombus. It's equilateral because it has 4 congruent sides. It's what? Because it has 4 congruent angles. What's that word? Maya. Equiangular. So what do you call it if it's equilateral and equiangular? What was that special name? Joey? Regular. A square is the only regular quadrilateral. Okay, so rectangles can be regular if they're squares, and rhombuses can be regular if they're squares. Okay, now look at that Venn diagram. That's showing you that rhombuses include squares and rectangles include squares. When you read this Venn diagram, you want to see it as the rhombuses are all of those. Okay, so rhombuses are everything in like that oval, and then rectangles is everything in this oval. Okay, that's rectangles. So that means that squares are rhombuses and squares are rectangles. So we know what a square looks like. I'm going to draw a little square in here though, just to remind us what we know about squares. Squares are equilateral and they're also equiangular. My square is a little too big. Okay, that's what a square looks like. Now, the rhombuses that are not squares would be the ones that are out here. Okay, what will they look like? What will they look like? Somebody who hasn't talked to me today. What will they look like? I like couldn't forgot who you were because I can't recognize back your head. Megan. Oh, sorry, Ainsley. Okay, these out here will be 4 congruent sides how do you know that they will not have 4 congruent angles? How do you know that? Ainsley, how do you know that? They're not squares. If they also have 4 congruent angles, then they're a square and they're not out here. Okay, these guys will have 4 congruent sides, but will not have 4 congruent angles, will not have right angles. Okay, squares have 4 congruent sides and 4 right angles, 4 congruent angles. Okay, the rectangles that are out here will look like what? Tell me what those will look like. And what else? You can tell me something else. Okay, they're congruent, so they'll also be right. There's something you can tell me about the sides though. What about the sides? Okay, can they all 4 be congruent or do they have to be different pairs? They're different, because if they were all the same, it'd be a square and it wouldn't be out here, it'd be in here. Okay, so not just that it has 4 congruent angles, it doesn't have 4 congruent sides. So the rectangles that are out here are going to have 4 right angles, but their sides will not be the same. And you're right that the opposite pairs have to be congruent, because again, this is a parallelogram. These are special kinds of parallelograms. So everything you knew about parallelograms in general are going to still be true about rectangles, rhombuses, and squares. Opposite sides parallel and congruent, opposite angles congruent, consecutive angles supplementary, and diagonals biased to each other. These were all properties of parallelograms. So everything you knew about parallelograms applies to these. Okay, so what kind of shape would be out here? Like if I made like another category here, what would make sense to for like the next category out? Oh, okay. So this would be parallelograms. Okay, and these would be ones that don't have 4 congruent sides and don't have 4 right angles. These would just be generic parallelograms. So okay, so these would be like that, but then these angles would not be right angles. Those would be the same. And then these would be the same, but not right angles. I guess I should probably mark that on the rhombus here. Rhombuses will have opposite angles, congruent, but they can't be right angles. So they're still going to add to 360. They're still going to be consecutive angles adding up to 180, but there can't be 4 right angles there. I'm going to add that property over here because that's something we know. In every parallelogram, angles add to 360. That's true in every quadrilateral, but something to remember. Okay, and if we went out a category bigger than that, you could have quadrilaterals. Okay, and then a bigger than that, you could have, what do you think? Polygons, yeah. Okay, so we're just focusing on special kinds of parallelograms here. So we're kind of taking parallelograms and sort of just looking at certain ones that have additional properties because they're more particular, they're more special. Okay, when you're looking at always, sometimes, never, true or false kind of questions, it is helpful to use the diagram. Okay, use the Venn diagram up here. So a square is always, sometimes, or never a rectangle. So if you're a square, you're somewhere in here, right? Are you always, sometimes, or never inside of the rectangle region? Lucy? Always. You're always going to be inside that pink area there, right? So that one will be always. Okay. If you're a rectangle, Are you always, sometimes, or never a square? I need to hear from some people who haven't talked to me. Yeah. Because why? Okay. It could be, again, the question was, is a rectangle always, sometimes, or never a square? It could be, right? If it's in the pink region, if it's a rectangle, it might be a square, but it might also be a non-square rectangle. Okay, the ones in here are, the ones in here are squares. The ones out here are the rectangles that have 4 right angles but don't have 4 congruent sides. So that's sometimes. Since there's 2 options there, that's a sometimes. A rhombus is always, sometimes, never a rectangle. A rhombus is always, sometimes, never a rectangle. I haven't talked to Neely. I haven't talked to Josh. I haven't talked to Jack Whitley. I haven't talked to Leah. I haven't talked to Emily. Neely, you want to answer? Go ahead. Okay, so tell me why. Talk a little bit louder. Okay, let me ask you a different way. If you're in the green oval, can you also be inside of the pink oval? Yes, if you're where? In the square. So is it possible for a rhombus to also be a rectangle? Sometimes. It's possible because a rhombus that is a square is also a rectangle. Okay, squares are both. Squares are, because they're equiangular, they're rectangles. Because they're equilateral, they're rhombuses. So this is sometimes true. And it's true when it's a square. Okay, so again, don't think of rhombuses as one category and rectangles as another category and them being separate. Remember that they overlap. They share some shapes, and the shapes they share are all squares. Okay, so again, a square, if you're in here, you're also a rhombus because you have 4 congruent sides. And if you're in here, you're also a rectangle because you have 4 right angles or 4 congruent angles. Okay, a rectangle, sometimes or never a rhombus. Emily. Yep, same thing as last time. I'm just going to cut and paste that. Oh, I really need to say squares. I'm going to say square. Okay. A rectangle is a rhombus, not when it's out here, but a rectangle is a rhombus if it happens to be a square in the overlap region. A rhombus, always, sometimes, never a square. A rhombus, always, sometimes, never a square. Leah. Okay, because why? Okay, so if you're a rhombus, you can be a square, but you don't have to be a square. Okay, so rhombuses out here don't have 4 right angles, so they're not squares, but it is possible for a rhombus to be a square. This one has a lot of sometimes. A square, always, sometimes, never a rhombus. Square. Oh, Jack. Always. So a square is always a rhombus because it's always going to be inside the green oval. Okay. A parallelogram is always, sometimes, never a rectangle. Josh. Always, sometimes, never. So if you're a parallelogram, you're like anywhere in, you're somewhere in this, on this chart, right? Is it possible for you to be a rectangle? Do you have to be a rectangle? No. So it's sometimes. Okay, Aiden. A rhombus, always, sometimes, never a parallelogram.
Sometimes.
Okay, when is it not?
When it's like four congruent angle, opposite angles are congruent.
So if I give you, to make this look more rhombusy, a rhombus has to have four congruent sides. And so if it has opposite angles congruent, is that a parallelogram?
Yes.
Is it possible for a rhombus to not be a parallelogram? Even if I go back to the, let me go back to, yeah. Is it possible for a rhombus to not be a parallelogram? So that's the definition.
Yeah.
It is possible for a rhombus to not be a parallelogram.
Wait, no, it's not.
Okay. So is it always, sometimes, or never?
It's always.
Okay. Rhombuses, rectangles, and squares are special kinds of parallelograms. Okay, so if it says this thing is a parallelogram, those are always going to be parallelograms. But the backwards way is the sometimes. Okay, so parallelograms in general don't have to have four congruent sides. They don't have to have four right angles. But if they do have those properties, they're going to be one of the special ones. Okay, some extra properties for rhombuses. Some extra properties for rhombuses. So you already know they have four congruent sides, and you know that they're going to have all the parallelogram properties. Okay, things that they also have. What is that showing? If you have a rhombus, then tell me what that says in the words. Seth, what are perpendicular? The diagonals are perpendicular. Okay, so that's something that's true in all rhombuses. Is that going to be true in squares? Will that be true in squares? Yes, because why, Maya? Squares are rhombuses. Okay, the diagonals of a rhombus are perpendicular. Also true in squares. You can also say rhombi. Rhombuses and rhombi are both plural for rhombus. So again, when you think rhombus, you need to think it could be a square or it could just be a rhombus. So when I say rhombus, it doesn't mean the rhombuses are not squares. When I say rhombus, I'm talking about anything in the rhombus category. So anything in here. Okay, so that includes squares. Okay. Second property, if ABCD is a rhombus, then, so what it's saying is that these angles are congruent and those angles are congruent. How would I know that all of them would get one mark there? It's kind of hard to see. Let me try again. How would I know that if I put one arc there that I wouldn't put two down there? How do I know that I'd also put one on those guys? Maya. Okay. It's a parallelogram, so the opposite angles have to be congruent. So that means, however, those two are split up, it's going to have to be the same situation down here. Also remember that these angles are what? Lucy. Alternate interior. This is a parallelogram, and those are alternate interior angles. Okay, so we know that those two are going to be the same, and these two are going to be the same. And then we also know that these two are the same, and these two are the same. Could all four of them be the same? Could all four of them be the same? Oh, if it's a square. In general, they will not be. Okay, but what you can say is the diagonals of a rhombus are angle bisectors. The diagonals are perpendicular and they're also bisectors of the angles. Okay, now remember that diagonal is also perpendicular in a rhombus. So if I have a rhombus, let me just kind of draw a rhombus over here. Like that. Okay, so if I go ahead and draw in the diagonals here, not my finest work. Let me try to. Okay, tell me things that I could mark if I told you that this is a rhombus. Tell me things that you know. Paul. Okay, it's a rhombus, so by definition, all four sides are congruent. Diana, tell me something else I could mark that this is a rhombus.
The diagonals are perpendicular.
Diagonals are perpendicular, so I know those are going to be four right angles. Okay. Ainsley, tell me something else I could mark. Okay, so this big angle and that big angle are congruent. How does that affect the angles in the little triangles? Because that's true in every parallelogram. There's something else that'll be true in a rhombus. Yeah. So these two would have to be the same and those two would have to be the same. Okay, now we also know, same thing the other way, these two have to be the same and same with those two. Okay, so a few things here. What can you tell me about these angle measures, that one and that one? Those angles are what? Lucy? Complementary. Because you have that right angle, you're going to have complementary angles there. Okay, what can you tell me about these little triangles? And actually, since this is a parallelogram, the diagonals bisect each other, so I could also do this. I didn't do that, but that's also true, right? What can you tell me about the little triangles? What is true about the little triangles? Jake, what's true about the little triangles? They're all congruent. So that's something that's helpful to know. I'll say it this way. Diagonals create four congruent triangles. So if you kind of think of a rhombus, if you were to fold it, it would fold down into one right angle, right? So if you fold along the diagonal, then fold along the other diagonal, they would all collapse down onto one of those, that like little green triangle there. So that's something that isn't given as a theorem, but something that is kind of helpful when you're trying to sort of remember the properties. If you can think of a rhombus as being four congruent, and they're right triangles too. One last thing. What could you tell me about this triangle? Anything special about that triangle? So it's isosceles. So you can also think about ballet, and then you could also create two congruent triangles that one would be congruent to this one, and they would also be isosceles. Okay, so something to kind of keep in mind. Okay, and then additional properties for rectangles. So we already know by definition of a rectangle, we already know that rectangles have 4 right angles. Again, that means they're equiangular, and they have all the properties of parallelograms. Okay, something that is special about rectangles is, what are they telling you there? If you know that's a rectangle, then the diagonals are what? Julia? Congruent. Okay, so the diagonals are congruent and they bisect each other because it's a parallelogram. So if I know that these lengths are the same, okay, and then also they bisect each other, those are the same. What do you know about this length? How many hash marks should I put on that? Joey, how many hash marks should I put on that little half there? That's my question. Which is it? So if this was 10, how long are these little pieces? Okay. And then if this is 10, what is this? Also 10, which means that those guys will also get one little hash mark there. So that's special about a rectangle, right? Not just the diagonals are congruent, but that means that since they also bisect each other, that's going to make all 4 of those the same. And that means these little triangles are what? That little triangle there is what kind of triangle? Isosceles. So that can be super helpful when you're trying to find angle measures. So in a rectangle, the diagonals will create isosceles triangles. You would also notice that like these 2 triangles would match up, they'd be congruent, right? And then this one would be congruent to that one. Then you also have a whole bunch of overlapping right triangles. So kind of notice that you have a right triangle here, and you have a right triangle here, and you have a right triangle here, and you have a right triangle here. So there's a whole bunch of right triangles in there as well. So when you're trying to, like some of the problems, they'll give you a couple of angle measures. You have to find all the other angle measures. Just kind of keep those things in mind because that's helpful to know. Okay, it's still a parallelogram. So for example, like those 2 have to be the same and these 2 have to be the same. But unless it's a square, the diagonals will not be bisected. That sounds like a dog, but I don't think it is. Okay, so squares are special. Rolly cart that needs some attention. A square is a parallelogram, so it has all the parallelogram properties. It's a rectangle, so it gets all the rectangle properties, which are these. Okay, 4 congruent sides, diagonals are, rectangle properties. 4 right angles and diagonals are congruent and then create isosceles triangles. And then it's also a rhombus, so it gets all the rhombus properties. Okay, and then it's also regular. Okay, so again, here's a chart that kind of includes parallelograms. So again, rhombuses are everything inside of here. Rectangles are everything inside of here. Hello.
Sorry.
Yeah, that's okay.
Super slow.
Thank you. And then squares are going to be part in there. Okay. And these are special parallelograms, but parallelograms in general are going to be having all the properties we talked about before. Generic parallelograms are going to be out here. So they will not be equilateral. They will not be equal angular, because if they were, they would be a special one. Okay, so those are the generic ones that don't have four congruent sides. The ones out here, it'll be a parallelogram with no congruent sides. I don't mean no. Without, let me say that way, without four congruent sides and without right angles. If you have, is it possible to have a parallelogram with one right angle? Bless you. If I tell you that's a parallelogram and I say it looks like that, what else could you figure out? Seth and Paul are working too hard. Somebody else tell me. What else could you figure out, Maya? Tell me why. Okay, it's not possible to have just one right angle in a parallelogram. So when I say without right angles, it can't have any right angles, because if it has right angles, it's going to have four right angles. If a parallelogram has at least one right angle, then all four angles are right angles. Okay, don't forget about all those properties of parallelograms. If you like looking at this as kind of like a tree diagram instead of a Venn diagram, so parallelograms have all these properties. Again, we added that angles add to 360. Okay, and then rhombuses, what were they using? Okay. Rhombuses have additional properties. Diagonals are perpendicular, diagonals are angle bisectors, and of course has four congruent sides, because again, that's the definition. Okay, and then rectangles have all those properties, plus they have congruent diagonals, and by definition, they have four right angles. Okay, and then squares get all those properties, so also squares are regular. They're the only regular polygons, quadrilaterals. Okay, squares are the most special, so they get all the properties of all the different shapes. Okay, we are going to stop there. And Carson, if you want to come over here and check homework, you can do that. By the way, I was seeing this mistake a lot on the quiz. You had this thing and you knew, sorry, you had this thing and you knew it was a parallelogram. And you would say A, B, C, D was given to be a parallelogram. And then you would say something like segment AB is congruent to segment CD. Definition of parallelogram. What's wrong with that? Somebody besides the three of them who answered 1,000 questions. Carson. Yes, thank you. Okay, so Jack, what do you need to write instead of definition of parallelogram? Okay, if I left that as a reason, this would have to say parallel, right? What if I try to say they're congruent? What do I need to write as a reason? Yes, in a parallelogram, opposite sides are congruent, or opposite sides of a parallelogram are congruent. The definition of parallelogram involves parallel. Okay, the only time you can use definition of parallelogram is when you say AB is parallel to CD, or if you say BC is parallel to AD. Okay, those are definition of a parallelogram. So these aren't definitions. These are what? That's not our definition. That's a theorem.